Thank you. How many of you here have heard of Kotlin? I'm joking. How many of you here use Kotlin? That's nice. You know, I always like giving talks on Kotlin in Japan because back in the old days, when we first created Kotlin, there was hardly anything on Twitter about Kotlin. Every time we used to come across a tweet, and we're like, oh, look, someone is tweeting about Kotlin, it was about ketchup, because in Poland, there is a ketchup called Kotlin. And then we started to see a lot of tweets, and they all came in Japanese. So I used to ping Yusuke and say, Yusuke, what are they saying? And so Japan actually has a very strong Kotlin community. So it's wonderful to always, come back here and see you all taking part in this. But anyway, I'm going to give you a brief history of Kotlin Anywhere, and then show you some things that you may not be aware of outside of Kotlin targeting the JVM. Also, I realize that you've already been here for 2.5 hours nearly, that the only thing between me and beer, you and beer, is me. I've got my beer right here, so I'm not in any hurry, but I will try and be as fast as possible. Okay? So we started Kotlin in 2010. When we started Kotlin in 2010, everybody said to us, why do you need a new language? But we decided to continue anyway, and we came out with Kotlin as the JVM, which is generally what all of you may be accustomed to. Our goal was to make it interoperable, and because we had code bases in Java, so we weren't a hipster shop, a startup that said, let's shut down and rewrite everything in the new language that is available. We needed to make everything work with existing languages. And we were targeting server desktop because that's what we were creating. And then at some point in our life, someone pinged us on the forum and said, hey, does this work with mobile? And we said, we don't know. And they tested it, and it didn't work, and then gave us a bug report, and we said, this is easy to fix. And eventually, it worked with Android. But Kotlin was never meant to be for Android specifically. Nowadays, sometimes you go somewhere and they're like, yes, isn't Kotlin a mobile language? No, Kotlin was never meant to be specifically a mobile language. In 2012, we decided to create Kotlin for JavaScript. Right? Now, why did we do that? Well, because everyone was creating a language that targeted JavaScript. And we thought, well, why not? We could do it as well. And generally, many of us feel that I'm not going to make any jokes about JavaScript. I'll just say that personally, I think that there are more appropriate languages to use than JavaScript in the industry. So we made it with JavaScript, and we did the same approach, which was we wanted to make it interoperable. Because we thought, again, it's not possible for you to have people create things from scratch. They need to be able to use that in conjunction with what is already available on the platform. And there we targeted both web front end, so you could have your web UI in JavaScript, or in Kotlin, and the Node.js server side, making it interoperable as well as we could with both. At the same time, we also launched Kotlin scripting, which was essentially the idea that I can now use Kotlin for scripts. So I could use it for different types of scripts as well as potentially host it. Some of those usages included build scripts, test scripts. You might have heard of Spec, which is a framework I started many years ago. Now someone else has taken over, which is kind of like a BDD framework, where you could use it for command line utilities. You could use it for routing scripts, like, for instance, Ktor, which, by the way, if you're not familiar with, yesterday, I believe it was, launched Ktor 1.0, which is a web server, client, and server application, and type-safe configuration files. So again, if you're not familiar with TeamCity, which is our continuous integration server, we use Kotlin DSL to configure build scripts. And last but not least, REPL, which is allowing you to kind of have this immediate feedback loop, which also gives way to the ability of actually using Kotlin for other things. And we are seeing an increase of people using Kotlin and adopting it for things like data science. In fact, we recently ran a survey at JetBrains focused around data science, and 7% of those we surveyed were saying that they want to or are adopting Kotlin as the language for data science. But there's still ways to go there. In 2017, we launched Kotlin Native. And last month at KotlinConf, we announced Kotlin Native going beta. And this essentially means that now you can target iOS, macOS, Android, all of the different things that you could potentially think of with Kotlin Native, including WebAssembly. And whenever WebAssembly is ready, hopefully we'll be ready as well. But this opens up a whole bunch of new platforms, right? Now I could potentially create Kotlin targeting multiple platforms. But once again, we wanted to make sure that we follow the same philosophy as before, which is try and make it interoperable. So there's a lot of things that are written out for Kotlin on the native field. You have a lot of C libraries, and we wanted to make sure that you can interop with C. You have Objective-C, because if we're targeting iOS, we wanted to make sure that you can interop with iOS and with Swift. If you're wondering whether Kotlin Native interops with C++, it does not, but as someone famously once said, C++ does not operate with C++ either. This allows you to create a slew of different target applications. So you can create mobile, you can create desktop, you can create system applications, and embedded types of applications. Now, Kotlin Native, because it is native, has some ways in which it works. To begin with, we are using LLVM, which means that any platform that LLVM targets, we can potentially target. It provides some runtime guarantees. In particular, it has support for exceptions and memory management. It is interoperable, as I mentioned, with some of the languages such as C, Objective-C, and we provide a series of wrappers for platform libraries such as POSIX, Apple Framework, etc. The way it works, if you're not familiar with how compilers work, you have a front end, which is what we have, which shares the code base across the different targets of Kotlin, and then we have backend. In this case, we're using LLVM, which despite its name is not a virtual machine. And anything that LLVM can target, we can now target with Kotlin Native. In terms of memory management, we have ARC recycle collector, which again, if you're familiar with iOS, it is automatic reference counting. In addition, we provide a cycle collector, which allows us to kind of avoid the problems of when you have circular references and potentially having leaks. Normally, that is managed in languages using weak references, and while Kotlin Native does have weak references, for cycles, it is not necessary to use. Now, when working with pure Kotlin, if you are just writing pure Kotlin, essentially that means that you do not have to really worry about memory management. And as I mentioned, weak references are supported. We do have, however, some primitives for memory management, memory allocation, pointer freeing, etc., when you are interoping with languages such as C. In terms of the memory sharing model, we basically have the idea that different threads have disjoint object graphs, which meaning that they cannot interlap. However, it is possible to transfer subthreads between threads. But what we're also trying to accomplish here is that try and move away from immutable shared objects, because we all know that shared plus mutable is essentially shooting yourself in the foot. So we are trying to enforce this at the language level. Now, this is great in that it allows you to target multiple platforms. But targeting multiple platforms provides or actually requires you to do other things. It essentially needs shared code. Because if I have a whole bunch of platforms that I can target, such as server, Android, iOS, or browser, I need the ability to be able to share code amongst these. Because if one of the benefits of using the same language, beyond actually knowing just one language and using it, oftentimes, if I am trying to do the same kind of development targeting multiple platforms, it ends up with some code that needs to be common, be this business logic, be this other things. Now, if you are writing Kotlin and you are targeting multiple platforms, you can start to share this common code. And if it is data classes or things like that, that is the same across all of these platforms, then it's absolutely no problem. You just write it once, and then you just share it and reference it on any platform you need. However, there are times when, based on the platform that you are targeting, the implementation may vary. And that's where we introduce the concept of expected declarations and actual declarations. And I'll show you a brief example of this later. But the idea being that this is very similar to the concept of interfaces and implementations. But instead of having something like an IOC framework, what you have is compile time declarations of certain common code that you can then provide implementations based on the different platforms that you are targeting. So if I'm targeting Kotlin.jvm, I provide an implementation on JVM for that common expected declarations. The same I would do for JavaScript, and the same I would do if I'm targeting Swift or what have you. In addition, we've now added support, working on support for multi-platform libraries, because there is common code that you could use across multiple platforms. So HTTP, serialization, coroutines, settings, loggings, all of these, it's our intention to provide these across all of the different platforms that Kotlin targets. Now, some of these are available to date, some of them are still in the works. But the idea being that with a single language, you can now start to target multiple platforms, and a lot of primitives that you are using over and over again, we would be providing. Other things, it's all about interoperability. Okay? So with that, I'm going to stop with the slides. I'm going to switch over to some code, and I'll show you some things in what is possible. Now, how many of you here are doing any kind of, oh, nice. Go away, go away, go away. How many of you here are doing JavaScript? 2 people. 3. See, there are some people that are like scared of putting up their hands. It's okay. No one's going to judge you for doing JavaScript. We've all done it in our life, right? It's nothing to be ashamed of. So here, for instance, I have some Kotlin code. And I've got different examples, but it's just to give you an idea of how this works. So I've got some Kotlin code. I've created a data class. I have a function that's called log output. All of this is Kotlin code. Now, when I am targeting Kotlin to JavaScript, I get a series of libraries, wrappers, for instance, the document wrapper for the DOM elements, etc., that I can work with. So for instance, here I have a DOM interaction, which essentially allows me to set the document color, set the elements of some element on the ID, and set some value to it. All of this statically typed. All of this is absolutely Kotlin code. And if I compile this, which I can just do something like Gradle assemble web, what that does, the first time it's actually a little bit slow. After that, it's fast. But the best thing that you can do is always look at this progress bar over here, which is a beautiful neon cat, which means, I don't know if my colleague Florian, you recommended this. This is not only a beautiful cat, it's also so that if IntelliJ ever goes slow, you never complain, because it's just so beautiful. Okay, so this has essentially created a JavaScript file for me. In fact, there are 2 files. One of them is Kotlin.js, which is the file that we essentially ship with some primitive standard library. And we try and make this as readable as possible. Then you can put this through your minimizers and your optimizers and whatever you want. But the file that it actually ships with the code, the compiled code, is sample.js. Right? So this is the code that has been generated for Kotlin. And you can have this code compatible with the different module systems that are available for JavaScript. So whether it's CommonJS, AMD, etc., you can set this as an option and it would be compatible. Because the idea is that you can call Kotlin code from JavaScript and consume JavaScript from Kotlin code. So I basically, the WebAssemble, essentially what it is a bunch of tasks in the Gradle file that decompress the output and ship it to a folder for me in web scripts, meaning that I can now open up my first.html and I can see the result of my work. Okay? And all of this obviously is just Kotlin code, nothing more. Now this is great for sample, but of course there's much more that you can do for this. So for instance, one of the things that we have done is the ability to create React applications. So if I come here, so I could do ref, just make sure that it's in temp, yes. There you go. Oh, taking too long. So I could do React, create React Kotlin app, my app, and what that does is generate the template, the standard template Kotlin React application for me, where everything is essentially Kotlin. And I'm using definitely typed, which is the header files for TypeScript, in order to generate all of the different components that I could use. Now, I will wait for this to go because my internet connection is really, it actually should be fast. I don't know why it's so slow. But do I have internet? There we go. So it's now downloading this, and while this downloads, which is going to create an application for me, unable to verify, yes, because I haven't logged into the internet. Let's go to El Mundo. Come on. There you go. Yep. You see? This is to prove that it's not Kotlin React Native that's slow, it's the internet. Okay, while that loads, what I will do is show you another application that's already created using this. So open recent, and we'll do client. Now this is the client-side application that we created for Kotlin Conf, which essentially what it is a rotation screen that shows tweets, etc. But all of this is statically typed Kotlin. So you see that this is similar to the whole concept of React, but these are not dynamically typed. These are actual static type functions. Okay, so I can create the HTML X library to mix all of my code here, and all of the components. I use CSS like I would usually use, and just basically using React the same way. Oh, here we go. There's my accept, yes. Doesn't matter, hack me. It's fine. Just, there you go. So that's launching. Now, while that launches, let me launch this one over here. So we'll open terminal, and then we do npm start, and then that will launch the browser, and will show me my application. Now this is rotating, so it has a little bit of a delay for each screen that it shows, but you'll see that it shows now the schedules, and then in about 5 or 6 seconds, it will show the tweets, and then after that, it will show something else, right? But this is all because of that's how the way the application is configured. In the meantime, that's still downloading. So all of this is basically allowing you to create applications that are fully written using Kotlin on the client side. And in fact, this application is using Kotlin on the server side and on the client side. So the server side is written in Ktor, the client side is written in Kotlin using JavaScript. Okay? That's when the internet goes down, which is now. Oh, there you go. Yes. See, I speak Japanese even. Yes? Okay. So that's Kotlin targeting JavaScript a little bit. But what you can also do is scripting. So let's open up our profiles, which is large. Okay? So here, for instance, let's go to Documents, Presentations, Kotlin, Anywhere, Scripting. So here, for instance, I have hello.kts. Okay? Nothing more. Just a hello.kts file. You see that? Just a sentence. No start, no fun main, nothing. And then what I can do is just write Kotlin C script, hello KTS, and what that will do is execute this as a script. So this allows me to basically write scripting with Kotlin as well. Of course, you can do a little bit more. So I have another example here, which is HTML main.kts. Here you see that I'm starting to use references of packages that are available on the JVM. And I use that using these definitions, annotations at the top, which is file, repository, file, depends on. Now, these aren't actually built into the scripting of Kotlin, but these are provided as a script definition in files that you can obtain and define your own, kind of like how Gradle would define its own scripting file, etc. So you can launch these different scripting definitions and then combine that with your actual script. So here I can do Kotlin C and run with the script definition, which comes in the format of a jar, and you can see that this basically compiles this and then uses it as a scripting. Now, right now, of course, what's happening is that it is compiling this the first time. But we are improving the scripting support in providing caching, etc., to make things a little bit faster. In fact, there's a community project that's called KScript, which provides a whole bunch of additional features already in terms of scripting. But imagine that we can combine this also with Kotlin native, and that provides us with even more value, right? And does this still download? There you go. OK, there you go. So now my JVS one has finished, and you can see that I've got my app over here, and you can see that I've got my JSON. So if we do less.packages.json, we can see that essentially it's NPM, right? I'm using the same ecosystem, everything the same, and yet all of the source code is all Kotlin. So index, and you see that I have KT files, right? And I do less. So all of this is essentially Kotlin. And then I could just do npm start, and that should launch my app just like we saw it before. Yes. OK? So this launches the default template, which then you can build on when you're doing JavaScript applications. And the second time, third time, et cetera, that you compile this, it is obviously much faster than the initial time. So that covers a little bit the scripting. It covers a little bit the JavaScript. But we also said that we have this last option, which is Kotlin native. So let's take a look at that. Native. Now, I'm going to show you, first of all, that I'm not just an IDE person. OK? I know my Vim as well. So native.kt. OK? So I can do fun main. By the way, remember that in Kotlin 1.3, you no longer have to pass optional arguments. You can just write main like that. Print line, hello, it's me. OK? And now, 1 second. Kill. I don't know how to exit Vim. No, I'm joking. Anyway, there. Whoa. WQ. And now I do Conan C native.kt. Now, Conan is the compiler for native. We've released Kotlin native beta, which means that it's basically feature complete. Now we're working on other things, such as the optimization, performance, etc. OK, so don't take much notice right now of how slow this is. Unfortunately, I don't have a neon cat to distract you. Now, if we do a list, we can see that this is program.kexi. Now, what is program.kexi? So that's actually interesting. First of all, it is why the Kotlin native team shouldn't name things. Because we're targeting macOS, and macOS doesn't have the concept of exe to begin with. Second of all, when we first launched Kotlin, someone wrote a library. I think the first library was probably called functional. And where it was there was a C, they replaced it with a K. And we thought it was quite funny and amusing. And now everyone does it. Even the Kotlin native team decided to prefix exe with a K. So no, don't do that. So what we'll do is we'll make this more friendly to macOS. OK? Now it's more friendly to macOS. And we run this, and you can see that no startup time, nothing. It's essentially native. Now, you notice that the size is a little bit large. And that is because we are including essentially the standard library with it. There is support for dynamic loading, static loading, all of these things that you can imagine. We also have Kotlin libraries that you can create, native Kotlin libraries, which they're called klibs, which you can then share code across multiple applications. But you want to do more than hello world here, right? And what I can do is interop with existing libraries. So there's a tool that we have which is called cinterop, which if you run it, it'll give you an exception because you need to provide some parameters. But what essentially this does is provide you with the ability to interop with C files, okay? And what you have to do is provide a definition file. So you can see that I've got this definition file that has essentially a bunch of options, and then I run this through cinterop, and what it does is create header files for me in Kotlin that I can then invoke the C libraries on. So I've run this previously, and it's given me the ability to call some of the C library function calls, such as the ones that come with lib curl, which allow me to do like HTTP requests, etc. So you can see that this is essentially just a header in Kotlin. And I use it essentially the same way that I would just write Kotlin code. I can call out to my C library and then execute everything essentially the same way that you would program this in C, you could do it in Kotlin. The difference is, of course, that you can now start to wrap this in nicer code. And much the same way that we saw how people are taking Java APIs and creating nice thin wrappers around them with Kotlin, providing idiomatic Kotlin, you could see people doing the same thing here. And that's kind of some of the things we're doing with Ktor HTTP clients, providing when we target native, we'll be providing an API in a Kotlin idiomatic way over existing C libraries. Okay? But all of this rest is essentially just standard Kotlin code. And you can create command line utilities, you can create desktop utilities using Qt. There's in fact already a project on GitHub that allows you to wrap Qt components. You can create iOS applications, etc. Okay? All of that with Kotlin native. Now, last thing is the multi-platform stuff, which I spoke about. Now, in multi-platform, as I said, what you want to do is have the ability to share code. So you can have code in a common module, and in that common module, anything that's a data class or any business logic, anything that is not particular to that specific platform is absolutely fine to share. But if you have different implementations based on the platform, you can even provide that with Kotlin. So here, for instance, you can see that I have a project where I have a common module, and then I have the common corresponding tests. I have a module targeting JavaScript, I have a module targeting JVM main, and I have a module targeting macOS. If we look at the Gradle file, you can see that I have all of these different targets. And each of them have their own set of dependencies. Okay? Now, in the common code, I actually have a file called sample, and this sample has a class called sample, an object called platform, and a function called hello. Difference is that it has this keyword in front of it, which is called expect, which means that this is some common code that you can call and expect that different platforms will have different implementations of it. So in fact, if I come over here and I say, hit Alt-Enter, you can see that it gives me the option of go to actual declarations. So if I hit that, it will say which declaration do you want to go to. Very similar to the interface implementation, except this is checked at compile time. So I say, well, I want to go to the macOS. And the macOS provides me with a check me that returns 7 and a string that returns native. Now, if I, no, not join lines. If I split this vertically, and if we go back to the expectation, if I say go to declaration of JVM, you see that the JVM implementation is different. So this now allows me to have common code, common interfaces that I can use across my project, and then for different platforms, define different implementations. Okay? So this is a little bit kind of opening up your eyes, if you weren't familiar with, that Kotlin is no longer just a language that targets the JVM, let alone a language that only targets mobile. In fact, this year, for instance, at KotlinConf, we had a substantial increase in people that were targeting non-mobile applications with Kotlin, right? But beyond the whole non-mobile, you also now have the ability, well, you've had for a while, for some time, to target JavaScript. And of course, now we're opening up the doors to many new possibilities with Kotlin native. If you want to see more samples, etc., there's an application online which we've created, which is the Kotlin Conf application for mobile, that it targets iOS, targets Android. It's the same code base in Kotlin. Don't look at the UI. It lacks a lot of features. But as an example of how to share code, it's a good example, and also the use of multi-platform libraries. And with that, it's all the time we have. I'll let you get to your beer. I'll be hanging around afterwards. If you have any questions, feel free to come up to me, and I'll be happy to answer them. Thank you.